In the single power rail double emitter configuration that we are busy analyzing now, we got to a point where the unloaded gain AVO has been approximated minus GM, the output impedance, which is on its own RC in parallel with RO, which can only be RC if RO is infinite, divided by 1 plus GM RE1. So that is approximated, of course, to minus GM RC alone divided by 1 plus GM RE1 in the ideal case. So that will be, this will be basically AVO ideal, meaning where RO is equal to infinite, or RO is just very big. But if there is a possibility to calculate RO, then you must calculate RO. Okay, very good. Now, the second type of gain to be considered here will be the half-loaded gain. Half-loaded gain. This is the gain that considers that has got only RL, no RS, or only RS, no RL. So one of the two, either RS is there present, or but no RL, or RS, or RL is there, no RS. So let's start with a half-loaded HL, half-loaded gain with RS, so no RL. So with RS, no RL would mean we have on this side, this means since there is RS, so as we go from VS, we go through RS, and then only we found VI, and then Rin. So VS is shared between RS and Rin, of which VI happens to be the voltage across Rin. If you apply voltage divider rule here, you get that VI is nothing but Vs times Rin over Rin plus Rs. So that fraction there, which is so Vi Vs times Rin over Rin plus Rs. We've got that fraction there. We're gonna see how important it becomes, because if there is Rs, that means automatically on the input side we're talking about Vs. On the there's no RL, so on the output side we've got VO still. So the half load again is V out over Vs in this case, which will be, this will be because there's no RL, so this will be V out is still the same, minus IC, if we consider that IC is beta IB, or plus IC if we consider that IC is minus beta IB basically, and this multiplied by R out, because VR didn't change, but on the input side we've got Vs. So now we want, since we already know V out over Vi, which is the unloaded gain or the open loop gain, and we have its formula, so we can create it in here so that we simplify the process. So all we have to do is to express Vs in terms of Vi, and that will be, Vs will be Vi times Rin plus Rs all divided by Rin. So if we replace that value of Vs in this half load again that we are calculating, then we get half loaded with Rs no RL to be equal to IC, or minus beta IB R out, divided by this side we're gonna have Vs, which is Vi Rin plus Rs over Rin. In fact, we don't need to even work out V out on top, because we can keep it as V out on top and Vi underneath. We get Rin now plus Rs over Rin. So because we know V out over Vi, and we've approximated that to minus GM R out over 1 plus gm re1, then it's just multiplied by well, it's just all of that multiplied by that fraction, Rin plus Rs over Rin. So the half-loaded gain in this case with Rs no RL can be computed as the open loop gain that we know, minus gm R out over 1 plus gm Re1, all of it multiplied by Rin, because the fraction, when we divide by fraction, the denominator of the fraction becomes the numerator, so it can go up, over Rin plus Rs. So to get to the half-load again where you consider Rs and no RL, you just have to multiply the already known gain, AVO, which is the maximum gain or the unloaded gain, by that parameter, Rin divided by Rin plus Rs, Rin that you will have calculated. This parameter is sometimes what we call input loading factor. Input because here it shows the impact of Rs on the unloaded gain. So when Rs comes in, what does the unloaded gain become? That's the idea. So that being said, that will be the half load gain. But what is this input loading factor having as effect on AVO in reality? Does it reduce AVO? Does it increase it? The answer is sort of given because AVO is the highest of all. So we can already assume that it actually reduces it. But let's prove it. Because if you've got the Rin over Rin plus Rs, considering that everything is positive because it's resistances, there's no negative value, then Rin will always be less than Rin plus something positive. Of course, 2 is less than 2 plus 1, so, or 2 plus 0.1 even. So whenever you, that being said, that will always be less than 1 then. And if you multiply something less than 1 by something else, AVO, it reduces it. That's why we say the open loop gain is the highest of all. The half loaded is lower, therefore. So the half loaded gain with Rs no RL is definitely lower than the open loop gain. We established that.